Hey everyone, and welcome. Today, we are diving right into the silicon hearts of all our modern gadgets. We're talking about the epic showdown between the two chip architectures that pretty much run the world, ARM versus x86. Let's get right to it. So, let me ask you something to get us started. On one hand, you've got your powerful desktop PC, right? And on the other, you've got a tiny, smart security camera. They both process data, they both think, but what do they really have in common? Well, the answer might surprise you. Way less than you'd think. You see, at their very core, their digital brains are built on two completely, and I mean completely different philosophies. It all boils down to two totally different ways of thinking, and that changes absolutely everything. Okay, so to really get a handle on this ARM versus x86 battle, we've got to go back to basics. We need to talk about the two competing philosophies that define how a processor even works in the first place. It all comes down to this thing called the instruction set architecture, or ISA for short. The easiest way to think about it is that the ISA is the fundamental language a processor speaks. It's the rule book that defines every single command the CPU can possibly understand and carry out. And right here is where those two philosophies really take shape. On one side, you've got CISC, which stands for Complex Instruction Set Computing. The goal here is raw power. It uses really complex, multi-step instructions to get a whole lot done with just a single command. The metaphor here is perfect. Think of a heavy, powerful gear. But on the other side, you've got RISC, Reduced Instruction Set Computing. This is all about speed and efficiency. It uses a much smaller set of super simple, single-step instructions that can be executed incredibly fast. Think of it more like a sleek, lightning-fast stream of data. So first up, let's talk about the long-reigning champ of that CISC philosophy, the one we all know and love from our PCs, x86. You know, the biggest advantage for x86 is its incredible history. It's powered our desktops for decades, and that means it has software compatibility that is just unmatched. If you want to run a full version of Windows 10 or 11 or a standard Linux desktop, right out of the box, x86 is your go-to. It's truly plug and play. And this is absolutely critical for so many businesses that rely on old but reliable enterprise software. But what's really amazing is how much these x86 chips have evolved. I mean, take a look at this real-world example, the UE2K1 board. It's got a 12th gen Intel processor that can boost up to 3.4 gigahertz. That is some serious speed. But the number that really blows my mind here is the TDP. It's thermal design power. You can just think of that as the maximum heat the chip puts out when it's working hard. And for this beast, it's just 6 watts. That is how you get a full Windows experience in a package that's tiny and super efficient. Okay, now let's flip the coin and look at the other side of the ring. This is ARM, the champion of the RISC philosophy. It's the quiet giant that powers pretty much every single smartphone on the planet. ARM's whole approach is just different. It's all about efficiency through integration. See, ARM processors are usually what we call a system on chip, or SoC. This means the main CPU, the graphics, and all sorts of other specialized hardware are all baked into one single piece of silicon. This all-in-one design makes them incredibly power efficient, which is exactly why ARM completely dominates the world of battery-powered devices. And when I say specialized hardware, I mean some serious, serious muscle. A high-end ARM chip, like the Rockchip RK3588, has an integrated neural processing unit, or NPU, that's capable of an incredible 6 trillion operations per second. And right here, you can really see that system-on-chip advantage in action. Take this board, the UU2YY3588. It's built around that powerful RK3588 chip. And just look what's baked right in. You've got that 6-TOPS AI engine, and you have dedicated hardware for both decoding and encoding 8K video. That is a wild amount of specialized power for a tiny device, the kind of efficiency a general-purpose CPU can only dream of. Okay, so we've got the powerful, compatible legacy of x86 on one side, and the efficient, specialized design of ARM on the other. So how do these two actually stack up when they go head-to-head in the real world of edge computing? Let's find out. When you talk about power and performance, it really is a classic trade-off. An x86 chip like that Intel N100 is generally focused on raw single-core speed. ARM, on the other hand, is the undisputed king of performance per watt. So while a modern x86 chip can have a really low 6-watt TDP, an ARM chip's power draw, especially when it's just idling, is often even lower. That's what allows for those compact, completely fanless designs that can just run forever.
Now, this is so important when it comes to software. x86's biggest advantage is its past. You can grab existing Windows software off the shelf and just run it, which means you can deploy things way faster. ARM is more about the future. It's for building these highly customized, super optimized systems that are tailor-made for a specific job, often running a specialized version of Linux or Android to squeeze every last drop of performance out of the hardware.
And this really gets to the core of the whole thing. In an x86 system, the CPU is the star of the show, period. But with an ARM SoC, it's more like an ensemble cast. You've got the main CPU, the GPU for graphics, an NPU for AI, and a VPU for video, all working together on one chip. And by putting all these specialists on the same team, ARM gets incredible efficiency for those specific jobs, something a generalist x86 chip really struggles with. And hey, don't ever mistake efficiency for a lack of power. Let's look at the raw numbers. Here we're comparing that high-end Rockchip ARM chip to a very capable 11th Gen x86 processor from Intel. And look at that! In both single-core and multi-core tests, the ARM chip is significantly faster. This shows that the performance gap isn't just closing. In a lot of cases, it's completely flipped. So, after all that, how in the world do you choose the right digital brain for your project? Which one wins? Well, the answer, as always, is it really depends on the job. You should absolutely 100% choose x86 if your project's success depends on running specific Windows software. I mean, if you've got a control system for a CNC machine that was built 20 years ago on a Windows app and it still works perfectly, don't mess with it. x86 is your answer. Its strength is that rock-solid backward compatibility. But you should choose ARM if your project is all about specialized, high-efficiency tasks that just have to run 24/7. Picture a smart retail kiosk. It needs to power multiple 4K signs while also using its AI brain to analyze customer foot traffic, all day, every day. And it has to do it silently, inside a tiny fanless box. That is the perfect job for an ARM SoC. Look, here's a simple checklist to help you decide. Question 1. Do you absolutely, positively need to run legacy Windows software? If the answer is yes, stop right there. Go with x86. Question 2. Is power efficiency, low heat, small size your top priority? If yes, you should be leaning heavily towards ARM. And finally, question 3. Is your main goal hardware-accelerated AI or video processing? If that's a yes, then ARM's built-in NPU and VPU give it a massive advantage. And that brings us to one last big question. For decades, x86 was the undisputed brain of all computing. But now, as AI and other demanding tasks are moving away from the cloud and directly onto our devices, out to the edge, the old rules are being completely rewritten. The battle isn't about which brain is more powerful overall anymore, it's about which one is smarter for the specific job. So, as we look to the future, which architecture do you think is going to power it?